Hello. Hello, can you see the screen?
Yes, ma'am.
Okay. So today we will learn about the disinfection method. In water treatment, we have already gone through sedimentation, coagulation, and flocculation, and then after means that is actually pre-treatment, coagulation, flocculation, and then sedimentation, and after sedimentation, filtration, and after filtration, which also removes like good amount of bacteria from water. uh, the last unit process is disinfection. Disinfection is the process in which we uh, try to kill the bacteria either by physical process or by chemical process. Physical process means like heating the water or boiling the water and boiling it for the long time, which is also known as to sterile the water. And then the other chemical processes are killing the bacteria using the chemicals like chlorine. Okay, and so these process we will learn. So here I have just put the definition of disinfection and like what kind of process of disinfection are being used. So now I start with the minor processes, which is like using the ozone, which produces the nascent oxygen. Nascent oxygen is a powerful oxidizing agent, and it can therefore it can kill the bacteria. Killing the bacteria means actually penetration of these chemicals through the cell wall of the bacteria and making the enzymes which are needed for survival of the bacteria to make those enzymes inactive. So the whole mechanism of killing the bacteria involves the penetration of chemical through the bacterial cell wall, and then inactivation of enzyme which is required for survival of the bacteria. So this is how it happens. So nascent, I have already told you this. 2 to 3 ppm of ozone is required to maintain a residual of zero point 0.1 ppm. Residual means what? Like after killing the bacteria, there should be some amount of ozone available in the water so that future contamination or any further growth of bacteria should be restricted. Okay, so that is called the residual. So zero point 0.1 ppm residual should be there in order to reduce any chance or avoid any further growth of bacteria during the distribution of the water after treatment. Residual ozone is measured by orthotod, tol, tolidine. Okay, orthotolidine test. I don't know what kind of test it is. If you want to further know about the test, you can search. It will be available. But I don't teach this experimental method or the like CVL100 subject where we also do the experiment. So I did not find out about this test. But if you want, I can also include that. Ozone is unstable, hence nothing remains in water by the time it reaches to distribution system. So it is very um, you can say um, difficult to maintain the residual ozone in water before it reaches to the distribution system. That is the disadvantage of using the ozone. It gives a pleasant taste to water. So UV treatment which happens in RO. uh, how many, like many of you have RO system at home, right? In that UV lamp is provided. That UV lamp doesn't do anything but it actually generates the ozone. So there are two, like this kind of UV lamp which generate the ozone and then produce the nascent oxygen, and therefore they kill the bacteria. So that is the method which is used. So after even like this treatment is being done at the like service level, right? Means after even the water is passing through the distribution system and we are receiving water at home. After that we are using the RO system to treat the water, further treat the water, kill the bacteria and use the water. So there is no requirement of like residual ozone to be there, because it will kill all the bacteria and the water will be safe. Other minor treatment is using UV rays. So UV rays which are 400 to 400 nanometer wavelength, there are different section of this rays uh, which are able to perform different tasks. For example, the UV radiation less than 240 nanometer cause ozone formation by photolysis of oxygen. Okay, so oxygen and nascent oxygen, they combine and they produce O3. Maximum O3 formation occurs at 185 nanometer. So this is what is being used in no, I think the second one is being used. The first one and second one combination is used in RO system. So UV between 240 to 280 nanometer causes destruction of ozone and formation of O2 and O. Maximum O3 destruction happens at 254 nanometer. And this nascent oxygen is powerful oxidizing agent which actually causes the killing of bacteria. uh, UV between 280 to 315 absorbed by ozone. Okay, so in this range, whatever UV radiation would be there, it can be absorbed by O3. And the UV between 315 to 380 is safe and not affected by any oxygen or O3 formation cycle. So this is how the UV is being used. These rays are highly effective in killing all type of bacteria. Thus, in a truly sterilized water, the water to be treated with ultraviolet rays should, however, be less turbid. So, if the water is high in turbidity and it's like colored water, then this method is not effective. So means this method can be used for clean water. That is why generally for in water treatment plant this process is not being used. In small RO or UV cleaning system at home, like a domestic system, this method is advantageous and being used. Normally, it should be used in colorless water and less turbid, means turbidity less than 15 mg per liter. Okay, the most common method, which is the major method and being used mostly in worldwide, is the use of chlorine. So chlorination is a process where chlorine is applied in water and for a certain contact period, and during that chlorine reacts with H2O and form HOCl, OCl minus and Cl2 at different pHs, and the most effective pH is between 5 to 7. Okay, greater than 5 and less than 7. The most powerful killing agent is HOCl, hypochlorite. okay, which is much more destructive than OCl minus ion. Okay, so this I have given in the like in below this the reaction is given, and at certain pH the um, if ammonia is also present there, then chloramines will also form. Okay, and chloramines are less powerful compared to HOCl. Okay, so we should avoid the formation of chloramines. However, the range of pH is very thin, in which only HOCl will remain. If NH3 is present in water, then it is almost not only difficult, impossible to avoid the formation of chloramines. So generally the chloramine and HOCl and Cl2, these are like chloramines are called combined chlorine. Okay, HOCl and Cl2, if they are present, they are combinedly called as residual chlorine. So these are the compounds which are responsible for killing of bacteria. Chloramines are slow killer of bacteria compared to HOCl, but they also kill the bacteria. Okay. So chlorination here, the further description is given. Chloramine are combined form of chlorine, as I said, right? It's a combined chlorine. It is less effective than the free chlorine. Free chlorine is HOCl and OCl minus. These are the our Cl2 if present there. Then these are the free chlorine. In the usual chlorine treatment, in which pH is kept slightly less than 7, so 5 to 7, dichloramine is most common. Okay, so between 5, like less than 7, 6.5 to, I think I have written here dichloramine 5 to 6.5, right? So in this range, which is slightly less than 7, dichloramine is most prominent, predominant compound. These disinfectants kill those enzymes which are essential for metabolic process of the living organism, which I have already explained you. The dose of chlorine should be sufficient so that it leave at least zero point 0.2 mg per liter of free chlorine, residual chlorine. Residual chlorine means free plus combined chlorine. Combined means chloramines, etc., and free means HOCl, OCl minus whatever. So it should at least leave zero point 0.2 mg per liter of residual chlorine after 10 minutes of the contact period. So like if 10 minutes we have passed the chlorine through the water, and 10 minutes we have allowed the bacteria to be killed in the water, then after 10 minutes at least zero point 0.2 mg per liter of chlorine should be available for further reduction of any further contamination, chance of contamination, you can say. The dose is called the chlorine demand. So the total chlorine applied to the water and whatever residual will remain in the water, the difference of these two value is known as the chlorine demand of the water. And the chlorine, residual chlorine, can be determined by DPD test. Okay, just you can read the whole name. It's a very complicated. uh, then so these are the reaction given for monochloramine, dichloramine, nitrogen trichloramine, how they form. Now this is very important to know, like when like what are the different reaction that happens inside the water, and when this they like free chlorine will be available. So as I explained earlier also, first when you apply the chlorine in the water, the inorganic and organic impurities both will react with chlorine. For example, if there is any ferric ion, ferrous ion, sulfur ion, or manganese ion or nitrite, they combine with chlorine and they form some compounds. Okay, so this inorganic impurities actually consumes the chlorine first. Okay, then further at certain point C, the organic compounds start oxidizing by chlorine. So they will be oxidized by chlorine, and it will leave a very bad smell in the water. And after the all organic compounds will be oxidized, so it will consume the chlorine drastically. The free chlorine or combined chlorine will drop down between C and D, and once this all organic compound will be oxidized again at point D, the chlorine will be available as a free chlorine. Okay, free and combined chlorine. But now there is no further reduction of chlorine which is being applied in the water. So point D is known as the break point. So after break point, the chlorine will be available as free and combined chlorine for further killing of bacteria in case there is recontamination or regrowth of bacteria in water during the distribution of the water or in distribution system, you can say it like that. So this curve is explained on this, which I have already explained you. The stage 3, the free chlorine breaks down chloramines into nitrogen. So in stage 3, which is the this one, right, third stage, so into nitrogen compound and chlorine, chloro organic compounds and destruct. So this is what the oxidation of organic compound happens, right, here in stage 3, and the chlorine is consumed in a large amount for oxidation of organic compound. However, mostly in water, the consumption of chlorine by ammonia is greater than organic compound. By ammonia means formation of chloramine takes more chlorine. Okay, so in general, that is the trend we see. Organic contamination is not that much. It doesn't contribute that much. Okay, so breakpoint chlorination I have explained you. This is two like problem statement. You can go through it. It is very simple. The total amount of water which need to be or water demand is given, and the bleaching, the chlorination is by bleaching powder. So you need to learn about what different type of chlorine, how the chlorine is applied, in what form it is being applied. In order to know that, you can refer this book. I will tell you the page number, and even I will tell you the names of the different compound. But let me just see if I have it on 1 minute. Sure. Yeah, so there are liquid chlorine or chlorine gas can be applied. Okay, and bleaching powder. So bleaching powder is CaOCl2. Okay, CaOCl2. Okay, another chlorine compound which is sometimes used for disinfection of water is bleaching powder or chlorinated lime or calcium oxychloride. Okay, three names: bleaching powder or chlorinated lime or calcium oxychloride. Okay, its formula is CaOCl2. Okay, so this particular example is very easy. If you go through this example, you will learn how. So it's from the page number 485, 486. of the book. Okay, so that is all related to disinfection process. Let me see if 1 minute. How many slides are there in water distribution system? If it's okay, maybe I will not be able to cover it. But let me start this. Okay, so now the water distribution system we will learn. Is there any question on disinfection? Is there any question on disinfection? No? Okay. Let's go to next topic, which is water distribution system. So water distribution system, we know that the water we get for drinking is either the surface water sources or maybe groundwater we treat and use for domestic purpose. So this water distribution or what sources of water is all clear. We talked about that in the first class also when we started the characteristics of water and all. So groundwater system, okay, that is infiltration galleries, infiltration wells, spring wells, all this type of wells are given here. So that is another source of water. Now, distribution method. One method could be just gravitational system. That means we provide the water reservoir on high altitude, and the pressure, the water will come with like enough pressure. It will come down with enough pressure and can be distributed in a different part downhill. Okay, or at the lower altitude. So this is very natural system. No pumping is required, nothing. And but basically this is only good enough for hilly region, not for all the regions. Okay. So for plain area, we have to have a pump, and direct pumping method can be used for distribution of water. Okay, so pump the water to the high reservoirs and or maybe directly in the distribution system, and that is one another way of you can say distribution of water. So here I will just go through the lines I have written. In the direct pumping system, the treated water instead of pumping to the service or distribution reservoir is directly pumped to the distribution main. So distribution mains mean the distribution pipes, okay, where from where it is supplied to the home. Okay, so so wire is not pumped to the reservoir, okay, or the reservoir which is kept on the high altitude. So instead of that, it is pumped into the distribution system directly and reaches the home. The system is not economical as the variable speed of pump hinders the target to achieve the maximum efficiency. It is not economical because that means we need very uh, highly efficient pump with high power. Then only the sufficient you can say pressure can be maintained in distribution pipe, because it is not just one distribution pipe, right? One main, and there are many branches linked to that main pipe, right? To the home of like to the home of each you can say to each home, right? So not only we need to maintain the pressure in main pipe, but also in the branches the enough pressure should be there. So which is difficult. Now combined system, the combined system, in this system of water supply, pumping and gravity system is combined. The treated water is pumped and stored in elevated distribution reservoir or tank, and from the distribution tank, and it is fed to the distribution system by. So this is the typical system which we see in urban area. You must have seen like very large tank on high altitude, like in your city, and in those tank, which is also known as reservoir, the the water is pumped in those reservoir, and from there it is released to the main and branch or distribution system, main distribution system, and it will have the sufficient pressure to reach to the individual house. um, However, uniform pressure is maintained during the supply. Okay, so that is another like combined system. uh, Dead end system. Okay, layout of distribution system, this is different thing. The first was how to distribute the water, the means what is the method of distribution. But the second thing, now we are learning about what are the different kind of distribution system which can be laid down on the on the surface to provide the water in individual house. So one is dead end system. Okay, the system has one main pipe from which a number of sub mains bifurcate, and from each sub main several branched pipe emerge as known and are known as laterals. So here you can see one main pipe M is written. Okay, I will put the laser pointer. Okay, so this is the main pipe. Okay, then these are the sub mains. These are the sub mains S, and then there are branches B. Okay, these are the branches B. So this M is the main pipe, B is the branch, S is the sub mains, and cut off walls will be there. Okay, so you can close the wall if you don't want to supply the water in that particular area. So the walls will be used to control the flow of water in sub mains and the branch. Okay, so that is one system. Then grid system. In grid system, the whole area is closed with the pipes, means it's a kind of grid is formed using the distribution system. The system has one main pipe running through the center, and the lateral and branches pipe run in the grid. So this is the main pipe. Then sub main and branches will run in the. So basically, we can say the main pipe is the biggest pipe, which will have the like largest pressure, water pressure, and then sub main, and then the branches. Okay, so the pressure will drop from main pipe to sub main and then in branch. So enough paper pressure we need to maintain in main pipe and sub main, so that the enough pressure will be there in the branch to reach at each home. Okay, at each demand point. Demerit of this system, the system requires more length of pipelines and large sluice walls. Okay, the design is difficult and costlier. So it's a design is difficult and costlier. Okay, so then ring system. In ring system, the main pipe will be all over or around in like it will form a frame, and the sub main will be inside. It's like grid of the sub main. There is no branch pipe. The system has main pipe all around the area and the sub mains inside. So grid will be with sub main system. Okay, there is no branches. I don't think there will be any branch pipe. Okay, no branch is there. So basically, it's a high pressure distribution system. You can say higher than the other system. Then radial system. In radial system, you will have different reservoir. Okay, different water distribution reservoir in each for each area. So the whole area can be divided into 4 parts or 5 parts, and in each part we will have one reservoir for water supply, and that reservoir will provide the water in the branch pipes, and that will go to each individual home. Okay, so this is the radial system where main pipe will give the water to reservoir. Okay, so this is the main pipe, right? M is written, and it will feed the reservoir on elevated reservoirs, and then from that elevated reservoir the water will be supplied to the branch pipes, okay, or sub mains. Okay, now analysis of the pipe network. So how can we, so I told you that there is a head loss. Okay, there is a possibility of head loss in water distribution system, and we need to maintain the pressure, enough pressure, so that the water reaches to the demand point with sufficient pressure. Okay, and how to determine this head loss, that is what we are going to learn. Fixing the size of the pipe for pipes of simple distribution system, this is the objective of this particular analysis. After the layout plan of of distribution pipes and location of walls, hydrants, etc. is made. So what is hydrant? This is what it is shown here, okay, on the right hand side. So uh, whole distribution system has to be planned in such a way that at a certain location, depending upon the head loss, there should be walls, hydrants should be provided. Okay, and this is hydrant is fire hydrant. Okay, in order to quench the fire demand. Okay, so so we the whole distribution system will not only provide the domestic demand as well as the fire demand also. Okay, that is what in general you can see the distribution network will involve. So head loss in the pipe can be calculated by Hazen-Williams formula, and this is the formula given: HL is equal to 1 upon 0.094 into Q upon CH raised to 1.85, 1 upon D raised to 4.85, where CH is the 100 for cast iron pipe. So CH is the actually one of the coefficient, it is 100 for cast iron pipe. D is the diameter, Q is the flow rate, water flow rate. The other analysis of pipe network is Hardy-Cross method. The system of analysis, this system of analysis, the distribution of flow in the network is assumed, and resulting head losses are balanced. Okay, so one flow is assumed, and then depending upon the length of the pipe, the material of the pipe, because you are assuming the flow rate, you can determine the head losses in each pipe. Okay, in each branch, sub main and branch. Okay, the method are as follows. The algebraic sum of the pressure drops around a closed loop must be zero. So what is the assumption? That the algebraic sum of the pressure drop around a closed loop must be zero, means uh, if there is a pressure drop, let me just see if I have any. No, 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 no. That's not it. It would be good to have an example. Okay, example is here. Okay, let's do one thing. Um, I will put it in a different way. I will put the example first because it is difficult to explain theoretically. Okay, so the total head loss in x and minus x direction is like sum up, and then total head loss should be zero. This is what, but let me change this presentation. It is not very clear. The flow entering the junction must be equal to the flow leaving the junction. Okay, let me change it. It's difficult to explain in this way. I think I okay. Okay, so this is very important method. Actually, this is the method which is being like used all the time in like most of the cases. Hardy cross method is used to design the distribution network, and I want you to have a good idea of this particular distribution analysis. So let it be here, and we will see it in the next class. I don't think more than that I have anything. So just one, this topic will remain. I will rearrange this presentation. Okay. So is there any other question regarding distribution network? It's a very simple thing. I tried to have like very simple topics only because this is like a kind of informative course for you. Okay, so is there any question? Do you have any question? Any question? No? Okay. So next time we will see the Hardy cross method and we will start the wastewater treatment. Okay, wastewater treatment. I think I have 4 or 5 classes only. How many classes are there? Yeah, four only. How many classes are there? Anyone? Wednesday, you do you have class on Wednesday or is it's a holiday?
This Wednesday is holiday, and so Saturday is working as Wednesday, I guess.
Okay, so Saturday we will have class. Okay, so
I think Saturday is not Wednesday. I have to confirm.
what?
I'm
Saturdays,
not sure
Tuesday
if
we can have class.
Yeah, Tuesday and Saturday we can have a class, no? Because Wednesday we are not having class, right? Okay. So how many classes are there? Do you have you counted out? Because I need 4 class.
Yeah, 4 are easily there.
Okay.
4 are there.
Yeah, because in general, in this course, even in other courses, I just do not teach on last week before major exam. So I want to cover the topics at least 1 week before the major exam. So the week of major exam as well as a week before, I want to just finish a week before. So
And ma'am, what about assignment 2? When are you planning to release it?
okay, assignment 2 will be released today's 20th, right? So I told my TA to release the assignment 2. Uh, so Friday, Saturday we will have a class, okay, and then Tuesday and Wednesday, 28. So by 28, probably 28, I will try to finish the wastewater also. 28, maybe maximum. I will take one class on Friday, so 30th. Okay. When is your exam? Your exam is from 8th, right? So first
Yeah.
of May you will have the assignment. So maybe first, which is like Friday is 30th of April, 1st May. Okay, 1st May, which is Saturday, your second assignment will be released. And one quiz is also remaining, right? So one quiz probably, let me see, I have to have before 30th. Okay, or maybe first Saturday. Let me talk to TA. Okay, so assignment will be released on 1st of May. That is for sure.
So can we get like 2 days to complete the assignment?
No, you will get more days. It depends upon the assignment. If it's
Okay,
like
okay.
you require more days, then it will be given to you. So don't worry about the number of days. Fine. Okay. Let's stop presentation and also stop. So today we don't. 30-minute class is already over, right? 8:30. We need to have. Okay, 6.